Hi, I'm Janusz. I've been developing for Android for over 14 years now, and currently I'm an Android freelancer. Welcome to my talk about type safety and clear error objects in Kotlin. It's a big title, but this is a lightning talk, so I will only briefly touch some of the things that I find important. And for me, the most important thing is a special way of thinking about data that I acquired over the years, and that maybe is helpful to some people. And I will do this with this one method. It's my example for the talk. The method is called update timer. It takes an ID. Then it takes in minutes and seconds, and it returns a timer. It's a method that I personally have written a lot of times, and I guess a lot of you also. And it's not wrong to write a method like this, but there are some things that you can think about that you can improve. And what the message, I assume what the message does is it loads the timer with the ID, then sets the minutes value, sets the seconds value, and returns the updated timer. And I say assume because as a developer, if I use code from other people, I most often just use code completion, see a method that matches what I want to do, and then I start using it, often without looking at the documentation or the implementation. So it's really important that this method definition gives me a good idea about how this method works. And that's what I want to talk about in this talk, how to improve your code so that that the usability of the code is better for the developers using it, but also for the compiler. And if it's better for the compiler, that means that the compiler can help you find errors. And it can help you find errors really, really fast. So there's not much that is faster than catching an error the moment you write it down. So if the IDE tells you, no, this is not the way that you call this method, then it's faster than most of the other things that you use to find errors. It's faster than sending it off to peer review and then maybe off in testing, and then after we wasted 5 hours of other people, then we get back a feedback and we realize, oh, damn, I called this method the wrong way. And that is cheaper, it's faster, but it's also more fun for us as developers to catch these errors fast and don't have that many loops to find problems. And the first thing that I want to improve on this method is it takes in 3 ints. Int is a number, so the compiler says, okay, all numbers are good. I don't care which ones come in there. The compiler does not have any context about this number. So the compiler can't really understand what this number is about, and it can't make any or can't give any additional tips. So for example, if I just pass in milliseconds, the compiler would say, okay, it's a number, it's fine, and then the user gets a really, really weird result. Or in the second line, if I switch seconds and minutes, the compiler looks at it and says, okay, I got 3 numbers, everything fine, I will compile, and then when you test it, you see, okay, something is really weird with our timer. And that one is something that even in code review, where you maybe don't have the name of the parameter handy, so maybe it won't even be recognized by other developers. And then in the test phase, after 2 days, you get back a comment saying, hey, this timer is not working. And then the last one, since we don't really look at the method, maybe the method just displays value directly to the user. And then we show 70 minutes and 200 seconds, which is a very weird thing to do for a time. But since you don't have any context about these numbers, or the compiler, and we don't really have context about this, we show this 70 minutes instead of 1 hour, 30 minutes, 20 seconds. So an easy fix to this is to use an object that has more context, that is more specific, In this case, it's the duration. So this brings the code a little bit closer to the problem domain. So it makes the variable, well, it's still a number, but the number now has context. And the duration class can help us a lot in, it provides different methods. It allows me to instantiate with milliseconds, but the other person can just easily get out the minutes, and I don't need to care about all of this. This could also be an app-specific class if there's no class available, like duration. For example, if you're building an app that cares about body weight, you would have a weight class that can convert between different units and make sure that everything is fine for displaying. And that also adds context to the number and removes the basic int that we're using. So if you can be as specific as possible, make sure that your data is already in the correct context. The next thing about this method is the ID. So an int does not really have a good way of saying I'm an invalid ID. Some apps would use 0 for invalid. I also worked on an app that used all negative values as invalid, because 0 was the first thing that the database that the backend used put in there. So the first value had the ID 0. And it also made it hard to be consistent in the ID checks. On some places in the app, we would check for smaller 1, smaller 0, equal minus 1. So there were like different ID checks in the whole application. And having the ID as an int also allows us to pass in wrong IDs. So in the last line, I had an alarm object, I had a timer object, and I accidentally passed in the alarm ID. And the compiler looks at the int and says, yep, it's an int, so fine. I don't need to complain. And in the end, I update the wrong timer, or the app crashes because the timer could not be found. A very basic and easy fix to this would be using an ID class. So every ID has a specific class. Here I'm using a generic class, so I can have an ID of the type alarm, an ID of the type timer. And it also provides an isValid method. So at all places in the app, we have the same check for validity. And if you're not using Kotlin multi-platform and you're only in the Android context, you can use the value class. I think it cannot really be used in multi-platform at the moment if you interface with the other languages. But if you're only in Kotlin context, you can use the value class, and then the value will be inlined, so there will not even be a performance overhead once this is compiled. Speaking of performance, this is often one of the arguments against more types and against wrapping data. And but with our modern phones, this is nearly never the first thing that you should think about. Make sure that your code is as clean as possible. And then if you see a problem in performance, then start working on improving performance, not reduce the readability of the code because you think that would be more performant. So now I want to take a step back and look a little bit on a broader app architecture and how data moves through a whole app and how types change during this. Often apps are split into 3 layers: the data layer, domain layer, and the UI layer. And for every layer, I think there is a specific way about thinking of data. So in every layer, the data has to have a different appearance to make sense in this layer. And this means mapping from one type to another on the boundaries of the area, of the layer. So in data, we are very close to the metal. We get data from the backend, we get data from Bluetooth, we get all the things that the backend team says will never happen, like missing values, null values, empty strings, negative values, So all the stuff that you need to check. So our types are very unspecific and are very messy. And then the data layer is responsible for cleaning this up, for maybe mapping a string that we get from the backend into an enum or into some constants, or converting numbers into more specific types like durations, as I said, like weights, or maybe currency, where you add the currency information and money amount together in one helpful type. Then you have the domain layer, and here the data takes the form of the problem language of the app. So the single entities, the single types come together to form meaning in the problem world of the app. So we now have to make sure that our data makes sense in the business logic where we want to use it. So we map it from the transport and the persistence objects to something that makes sense in the problem world of the app. And here, I would say it's having too many types is more or less impossible. Be as specific as you can with your data, and add as much context as you can so that other people know what the data is about. And then we have the view layer, and in the view layer, the data now changes its form to be displayed. So we map from the domain and the problem language to a view language, to view states, and to bring our types into a shape where you can easily display the data, and where we only have the data that needs to be displayed. Maybe it's already translated, formatted, and everything. And here, that's, as I said, a way of thinking about data. For me, types is a little bit like clothing for data. So a type is a specific set of clothes that the data can wear. And the data needs a different clothes for being at the pool, going to work, or going to the opera. So don't be afraid of mapping your data often and changing the structure of the data so that it always matches the place where it is needed. And we now come back to our method. We already checked the input. And now I want to talk a little bit about the output. Here this method returns a timer. And it always has to return a timer. If not, the code will not compile. So what happens if I pass in invalid ID? And if you look at the implementation of the method, it loads the timer, and if the timer is not there, it throws an exception. And this makes it really invisible for people using this method that there's an error here. And most likely, I would just work with the happy pass. I, as a developer, would use it and say, nice, I got a timer. I will completely forget about the cases that I have to cover where there is no timer, where I need to catch the exception, rethrow it, and maybe then show an error to the user in the end. And there's an easy fix to this. In Kotlin, we could just make the timer nullable, and as a language feature, now the compiler forces us to think about the missing data. It makes it more explicit that this data may not be, that it's possible that this data is not there. I come from a Java world, so having a nullable in my classes always makes me feel a little bit uneasy. For me, a nullable feels like an unchecked explosive in the room, but in Kotlin, this also, for a lot of people in Kotlin, this is fine, because there's a language feature, there are a lot of checks, and you really have to want it to handle the null in the wrong case. Then there's an optional object from Java. This also makes it explicit that the value is not there. So the optional tell you is wrapper around the value and says, okay, there may be a value here. But since it's not a language feature, it's easier to use this in an unsafe way and without getting any information from the tooling that you are doing something wrong. And then I want to show you a third way. This is from a library, from the Arrow library. Arrow is a library that brings functional programming concepts into Kotlin, or more functional programming concepts into Kotlin. It's a rather complicated library. It's a big library. The documentation is not easy to read if you're not familiar with the functional programming mathematics. Yeah, I really like some of the concepts in there. And the either is an object that has either an arrow or has the timer. So in this closes the gap between the timer and the timer not being there. We now know why the timer is not there, because there could be different problems. If the timer comes from a Bluetooth device, maybe we are not connected. If the timer was configured in an invalid way because we sent in a negative duration, that is the difference to the timer not being on the phone in the database. And it's important for us as developers to show the right error to the user, because having one error dialog that says, oops, something got wrong, is not satisfactory anymore in modern apps. So that's why I prefer to use this, even if it brings with it all the arrow things. But if you get used to it, there are a lot of things in the arrow library that really help working with this. And arrow also helps you to have working steps where you say, okay, I only work with the right part of this, and if the error case happened, then I just pass it on to the next layer. And that brings me to my last slide, and it's something some people call it railway-oriented programming. I think it's a really big name for an easy concept, but the concept is named this way because most trains only use if they have two rails. You always have the happy path where you load the data, you transform the data, you map it to another layer, you work with it in some use case, combine it with other data, and then you display the result. And on the bottom, you always have the error path, where maybe the loading fails, the mapping fails. So on any step during the happy path, you need to be aware that you can change to the error path and to the other rail. So that's why I like the name, because it says, okay, if you forget the other part where the error can happen, then yeah, your whole app looks a little bit unstable. Okay, so that was a very short and brief introduction into some of my thoughts about how to handle errors, how to make or why to have more types and not pass in your database object to the view state in the end. And thank you for coming to my talk. If you have any questions, come to me after the talk or find me outside. Thank you.